Welcome back to the deep dive. It is February 2026. And if you've been trying to keep up with the tech headlines this month, you are probably feeling a little bit like you're drinking from a fire hose.
Oh, that is putting it mildly. The pace has gone from breakneck to, I don't know, instantaneous.
It really has. I was looking through our stack of research for this deep dive, technical papers, industry reports, all of it. And I had this flashback to, 2023.
hmm
Remember when we were all just impressed that a chatbot could write a haiku or a decent email?
It feels like a lifetime ago, like we were looking at the stone age of AI.
Exactly. Because looking at the landscape right now, in early 2026, we are not just talking about chatbots anymore. We're not even really talking about tools in a passive sense.
No, we're in the middle of a full-blown operational shift.
That's the perfect way to frame it. And what's so fascinating about this specific moment is that we're seeing this massive divergence. The road has split.
It really has.
Right. And that's the theme we want to get into today. On one side, you have these behemoths, these massive, almost godlike models that are running the world's infrastructure.
And on the other side, you have this explosion of, well, liquid models and these efficient, tiny brains that live right in your pocket.
It's the difference between a supercomputer in some guarded fortress and a brilliant assistant whispering in your ear.
And our mission for this deep dive is to move past the hype. We know AI can generate video. We know it can write code. That's old news.
Yeah, we want to understand how AI is becoming agentic. Actually taking action. How it's becoming adaptive through this new liquid tech, and crucially, why it's suddenly running on your phone instead of in the cloud.
And why that changes, well, everything, especially for privacy and speed.
So let's unpack this. We have to start with the titans, the heavyweights. Who is currently sitting at the top of the food chain in 2026?
It's a crowded summit, but the air is very thin up there. You really have 4 or 5 major players defining, the reality of the internet right now. And obviously, we have to start with OpenAI.
GPT-5. The rumors about this thing were flying for 2 years. Now that it's here and integrated, is it just GPT-4 but faster?
No, it's fundamentally different. The key word here is reasoning.
We've heard that word a lot. What does it actually mean in practice?
Well, think about the old models. Even GPT-4, they were basically just predicting the next word in a sentence. It was all probability. Very system one, thinking fast, intuitive, but
prone to just making stuff up. Hallucinations. The bane of my existence.
Exactly. GPT-5 creates a kind of thought trace before it speaks.
Yeah.
It simulates multiple outcomes internally. It weighs them, checks its own facts against the data it has, and then it gives you an answer.
So it's system two thinking. Slow, deliberate.
Logical. It's thinking before it speaks, in a manner of speaking. And that drastically reduces hallucinations. It allows the model to handle these agentic workflows, actually doing things without breaking everything.
Okay, so that's the brain. But then you have Google with Gemini Ultra. Are they just playing catch-up at this point?
I wouldn't call it catch-up. I'd say Google played a different card entirely. They went multimodal native.
Meaning it doesn't just see text?
Meaning it was never just text to begin with. You see, most models are trained on text, and then later on, engineers sort of glue an eyeball onto them so they can process images.
Right.
Gemini was born with eyes and ears. It processes video, audio, and code all at the same time, natively.
So if you're a developer trying to debug a video rendering pipeline or an analyst watching hours of footage.
Gemini is really the only game in town for that. It understands the flow of time and media in a way that the text-based models really struggle with.
And then there's the open source side. Meta.
Llama 4, the champion of the builders.
The headline I saw for Llama 4 was all about the context window. They're talking about 10 million tokens.
It's a staggering number.
For our listeners who aren't engineers, what does 10 million tokens actually get you?
It's basically an entire library of books in a single prompt. In the past, if you wanted an AI to learn your company's entire history, you had to use this complex technique called Reori.
Retrieval augmented generation.
Yeah.
Yeah, you had to chop up the data and feed it in spoon by spoon.
Which was messy and prone to errors. With 10 million tokens, you just dump the entire database, every email, every manual into the prompt and say, analyze this.
Wow, it holds the entire context in its working memory at once.
Yes, that changes the game for legal discovery, for medical research.
Yeah.
It makes the AI less of a search engine and more of a comprehensive analyst.
But this is where I get a little skeptical. We have these massive models. They're smart. They have huge memories. But they're also incredibly expensive to run.
Massively.
You can't put GPT-5 inside a robot vacuum.
No, you definitely cannot. And that energy cost, that compute cost, is what triggered the second base shift we are seeing in 2026, the revolution in efficiency.
This is where that liquid concept comes in. The sources mention liquid foundation models. Now, I love a good metaphor, but when I first read this, I thought it sounded a little like marketing fluff.
It does sound buzzy, I'll give you that. But the math underneath is actually a radical departure from the last 10 years of AI architecture.
How so?
Okay, think about how a standard LLM, a transformer, works. It takes a snapshot of the world, your prompt, processes it, and gives an answer. It's static.
Like a photo album.
Exactly. Once the model is trained, the connections inside it are frozen. They're a solid block of ice. A liquid neural network, or LNN, is based on differential equations. It functions more like a biological brain.
So it processes data as a continuous stream.
Like a movie, not a photo album. It understands change over time. That's the liquid part. The parameters of the model, the brain cells, if you will, they actually adapt and shift while the model is running.
Wait. The model changes after it's trained, while it's being used.
Yes, in real time. It adapts to the input.
That is huge, because usually if the world changes, the old model just fails.
Precisely. And because these liquid models are adaptive, they are incredibly efficient at handling things that change constantly, like self-driving cars, robotics, even battery management on your phone.
And the sources say you can run these on a Raspberry Pi.
A Raspberry Pi, a standard edge device. Because they dynamically allocate resources. If the car is on a straight highway, the model relaxes, uses less compute.
But if a deer runs onto the road,
The liquid state shifts, and it applies maximum compute instantly.
that is wild. It's dynamic intelligence.
It opens up robotics in a way the big transformers never could. You don't need a connection to the cloud to make a split-second decision.
Which brings us directly to the device in our pockets. Because if models are getting smaller, more liquid, more efficient, they can leave the data center.
This is the on-device revolution. And frankly, this is the part that affects your daily life the most.
Why? I mean, 5G is fast. Why do I care if the AI is on my phone or in a server farm in Virginia?
3 reasons: latency, cost, and the big one, privacy.
Okay, let's break those down. Latency first.
Speed. A round trip to the cloud takes, what, 200 to 500 milliseconds? That sounds fast. But for real-time translation or for augmented reality, that delay is nauseating. It feels sluggish.
And on device?
It's effectively instant. It feels like magic.
Okay, but let's talk about privacy, because I think that's the real driver here, isn't it? We spent the last few years being terrified that our data was being sucked up to train these giant corporate brains.
And those were valid fears.
But with these efficient on-device models, the mobile LMs, the smaller llama models, the whole dynamic flips, doesn't it?
Completely. If the model runs on your Apple A19 chip or the Snapdragon 8 Elite, your data never leaves your pocket. You can have an AI analyze your entire medical history, your bank statements.
And OpenAI or Google never sees a single bite of it.
That's the promise. The air-gapped personal assistant. It's a personalized intelligence that knows everything about you but tells no one.
That sounds great, but I have to play devil's advocate here. Is the hardware really there? I mean, my phone gets hot just scrolling social media sometimes. Can it really run a 7 billion parameter model without melting?
It can, yeah, but not by brute force. We aren't just shrinking the chip, we're changing how the math works. That's where the quantization breakthrough comes in.
The sources mentioned 4-bit is the new default. Break that down for us.
Sure. Imagine you have a high-definition photograph, a massive RAW file. It's beautiful, but it takes forever to send. Quantization is like compressing that photo into a high-quality JPEG.
You lose a little bit of detail.
A tiny bit. Maybe the shadows aren't quite as sharp, but the file size drops by 75%. We're doing that with the brains of the AI. We used to store model weights in 16-bit formats. Now we're finding that 4-bit or even 1.58-bit works almost as well.
So you're compressing the intelligence without making the model stupid.
Exactly. You fit a Harvard education into a file size small enough for a smartphone.
There was one more technical trick in the notes that I just loved. Speculative decoding.
Oh, it's a fascinating technique. The best analogy I've heard is the boss and the intern.
Okay, I'm listening.
So running the big smart model, the DOS, is slow and expensive. But you have a tiny fast model, the intern, running right alongside it.
Right.
The intern guesses the next few words of the sentence. It drafts the email for you. And since it's a small model, it does it instantly.
And then the boss model just scans the draft.
Yep. It doesn't write it from scratch. It just stamps approved
Yeah.
or makes a minor correction.
Because checking work is faster than doing it?
Much, much faster.
Yeah.
It creates this illusion of super speed because the heavy lifting is only done when the intern really messes up.